over 36,000 high schools in the United States. This includes 26,000 public schools and 10,000 private schools. This is a map of graduation rates for high schools across the country. Graduation rates vary widely by geography. In some school districts, almost everyone graduates. These regions are indicated on the map in dark blue and have graduation rates above 95%. School districts with lower graduation rates are indicated on the map in green. Some of these districts have graduation rates lower than 70%. The differences are easier to see on an individual school level. Take a look at East Brooklyn Community High School in Brooklyn, New York. This school has annual graduation rates as low as 27%. Now let's go just across the river to Millennium High School. Millennium High School sits in an affluent part of Manhattan. Over the last 3 years, Millennium has graduated 100% of its students, not 99 or 99.5%, 100%. This means that every single student in the last 3 years has graduated from high school on time. This type of educational inequality isn't unique to New York City. Across the country, wealthier school districts graduate a higher percentage of their students. Now let's compare a map of graduation rates to a map of income in the United States. There is clearly a large overlap between dark areas, places with high income and high graduation rate, and the light areas, places with low income and low graduation rate. Areas like Florida, West Virginia, and New Mexico have some of the lowest median incomes in the country and show low graduation rates. On the other hand, Northern California and Northern Virginia both have high median incomes and high graduation rates. Household income affects taxes, which affect the quality of education, which directly affect the number of students that obtain a high school degree.
So it makes sense that we see some correlation between household income and graduation rate. But how heavily are these things related? And what are the impacts of other factors, like unemployment rate and ethnicity? Can we use these things to predict graduation rate?
To answer these questions, we need data. This data set was obtained from the U.S. Census Bureau. Although the census has a very confusing website, it has a comprehensive data available on every population statistic you can imagine. Everything from the number of handicapped people to the number of people who have health insurance. Looking at the data, we can see we have a lot of subcategories like the different age groups, gender, and race. It's nice to have all this data, but there's a lot of redundant information. Plus, the columns contain things we don't need, like the error bounds and versions of each statistic. So let's remove all of this unnecessary information and work with the overall statistics for each category. That's better, but there's still a lot of columns here. We don't want to pick too many features and overcomplicate the model or confuse it later on. So let's handpick the statistics that we think are relevant to the problem and work with those. Look at that. We've taken a massive data set from the Census Bureau and reduced it down to a few meaningful columns that we can use to predict high school graduation rates. Let's look at the correlation between these variables. Looks like we have some serious underlying meaning in our data. We just have to figure out what it is. Let's try our first model. Looking at the first model using a linear regressor, it has an RMSE of 9.394. Not too bad, since the graduation rates in our data set vary from 30 to 100%. Nice. But let's see if we can improve upon this. So, looking at the decision tree, we have an RMSE of 7.240, which is a slight improvement from our linear regressor model. Not bad, but let's see if we can do even better. Let's try using a random forest. So looking at the random forest, we have an RMSE of 4.035, which is a great improvement from our other two models. That's not bad. An RMSE of 4 means that on average, we were able to predict the graduation rate of a school district or county within 4% of its actual value. Impressive. However, we thought this might be too much data. So to predict the graduation rate of Virginia schools, it might be more telling to only look at the data from Virginia itself. So let's take a closer look at Virginia. Similarly to before, we got the data from the U.S. Census Bureau, but this time only for Virginia. Like with the USA data, we didn't want to pick too many features and overcomplicate the model, so we handpicked the statistics we thought were relevant to the problem and worked with those.
We limited our data set to only the 95 counties in Virginia, along with a few independent school districts. The graduation rates in Virginia were on average much higher than in the United States. The linear regression we ran had an RMSE of 2.294. This looks very good, but then we looked at the range of graduation rates in Virginia and realized that most of the graduation rates are between 90 to 100. So it does really make sense that we have a relatively smaller RMSE value. Now, using the just means predictor, we get an RMSE value of 3.069. This is slightly worse. Now using the decision tree predictor, we have an RMSE of 2.219, which is pretty much the same as our linear regressor. And now using a random forest predictor, actually improved. We were able to predict our results with an accuracy of 1%. Limiting our data set to only statistics relevant to the state of Virginia, we were able to predict graduation rates within 1.3%. In summary, when we trained models on data from every school district in the United States, we were able to predict graduation rates within 4% using a random forest. But when we limited our data set to schools in Virginia, the model actually improved. We were able to predict our results with an accuracy of 1%.